Good afternoon. My name is Jisoo. It's a great honor to have an opportunity present at Code Blue 2016. In this summer, I and Inhyuk attended Black Hat at DEF CON, and the best interest of the DEF CON is CGC, Cyber Grand Challenge, the world's first all-machine hacking tournament. Only with a few of engineers' initial participation, the machines detected vulnerabilities, attack, and patches for themselves. It was very awesome. Usually, I research about security evaluation and certification. Ideally, the result of security evaluation and certification must be same without reference to tester or evaluator. And less time and cost for evaluation may be better. Achieving higher security evaluation level means that we need some techniques to make clear and objective results, no matter who tested, who evaluated. So it is recommended to use some tools to help security evaluation. This is a main motivation of our presentation. Actually, there are no tools only for hacking or only for security evaluation. There are only tools on roles and goals. On the flight coming back from DEF CON, I think CGC's fully automated vulnerability detection techniques and tools can help make security evaluation and result objective, including vulnerability assessment. In this presentation, Inhyuk and I analyzed some tools for design assurance and security testing and want to discuss about the possibility of applying fully automated tools with security evaluation. Our presentation consists of two parts. First part is I will tell you why we should use automated tools and why it is important. Second part, we will describe some tools for design assurance and code assurance. We choose some assessment items from the point of view of security evaluation. Also, we prepare some demo videos about using tools. Let me start by saying just a few words about us and my professor. Both Inhyuk and I completed a high-quality information security education course that called Best of the Best. And now we are in master course in Korea University, Graduate School of Information Security. We are in SANE lab, Security Analysis and Evaluation lab. This is my professor, Seung-Ju Kim, and corresponding author of this presentation. He is interested in cryptography, security evaluation, information assurance, and so on. Last year, he also presented Code Blue 2015. The title is How South Korea Invests in Human Capital for Cybersecurity. At first, I think it's pretty useful to form a consensus for better understand my presentation. I think you have heard assurance. Assurance, it means that level of trust it does. And then information assurance means that degree of trust in the information. I want to talk about the background, the rise of the information assurance. In 1980, it was InfoSec era. InfoSec means information security. And the first concept of information assurance appeared in 1991. With Gulf War. Sometimes Gulf War has often been called first information war. In the book Security Engineering and Information Assurance, written by Deborah Hellman, he quoted some reports. You can see the below box. At the height of the operation, the system supported 700,000 telephone calls and 152,000 messages per day. More than 30,000 radio frequencies were managed to provide the necessary connectivity and to ensure minimum interference. It includes some information assurance concept, and that's why Gulf War is often called the harbinger of information assurance. And after that, in 1996, U.S. Department of Defense defined the first standardized definition for information assurance in their directive. In the DoD Directive 5/3600.1, now the Directive DoD 8500.01E, the definition of information assurance is written like this. It includes security property such as availability, integrity, authentication, confidentiality, non-repudiation, and restoration. And then, what are the differences between information security and information assurance? The goal of information assurance includes not only confidentiality, integrity, availability, but also include non-repudiation, accountability, auditability, transparency, etc. And also security mechanism includes all available such as technical, organizational, human-oriented, and legal. To sum up briefly, information security is protecting information and information systems from unauthorized access. And information assurance is validating that the information is authentic, trustworthy, and accessible. Then how can you achieve information assurance? Now, I will talk about the way to achieving information assurance. What is information assurance? Information assurance defense from hackers' attack or operating during emergency like natural disaster. Let's see the picture. The dependability of a system reflects the user's degree of trust in the system. It reflects the extent of users' confidence that it will operate it as users expected and that will not fail in normal use. As you can see, for dependability, there are 4 properties: availability, reliability, safety, and security. Let's see next page. 4 elements about dependability I mentioned before are not independent of each other. They interact with each other closely and complicated. For example, adding state-of-the-art technology into smart devices may affect security feature of the devices. So we must consider all 4 elements during the whole system lifecycle. Even a few years ago, usually in security area, they consider security, availability, reliability are mainly considered. And other area like automobile, air traffic control system, mainly considered safety, reliability, and availability. In case of automobile, security was low at first, but now it is medium because network system which can affect directly to driving are applied to automobile. Pictures in the right are Charlie Miller and Chris Balasek's presentation at DEF CON 23rd. I think you guys already know the presentation. They showed what can be happen if the car is hacked. It's very terrible. And then, how can you achieve information assurance? The answer is security engineering. Ross Anderson, professor of a computer laboratory in University of Cambridge, wrote security engineering definition in his book like this. Let's see some keyword. Remain dependable focuses on tools needed to design, implement, and test complete systems and to adapt existing systems as their environment evolves. It means that all phases in the system lifecycle must consider dependability. For achieving information assurance, assurance must be considered in each system's lifecycle phase. That is, policy assurance, design assurance, implementation assurance, operational assurance are needed. Security engineering can give a systematic method and be applied to whole system lifecycle. There is a specific and detailed description for system engineering lifecycle process in a lot of standards. For example, International Standard Organization or Common Criteria and CMVP and CNA. Okay. But usually, that can be simplified with 5 phases below: requirements, design, implementation, release, and maintenance. Security engineering can be checked every phase in this phase. This is an example case of a security development lifecycle. This is a Microsoft security development lifecycle. There are 5 phases in the center of the lifecycle, the green zone. Large boxes in each phase means that the activities for security engineering. Besides, many IT company or organization have their own security development lifecycle, like Cisco, OWASP. Yeah. I wonder that security development lifecycle really work, and I found a report from Microsoft about SDLC. These 2 graphs shows the number of vulnerabilities before and after SDLC for Windows OS and Windows SQL Server. As you can see, there are 46% and 91% decrease in rate, respectively. I think it will be more efficient as long as the specific techniques in SDLC are developed continually. As I mentioned earlier, assurance means that the level of trust. Then what is a high assurance? Let's talk about the high assurance. As you can see in the text box, high assurance means that it can be mathematically proven that the system works precisely as intended and designed. And also, high assurance development means that there are clear and compelling evidence in each development phase. Before we talk about high assurance for CPS, let's check some points about CPS shortly. CPS are co-engineered interacting network of physical and computational components. CPS is the foundation of the critical infrastructure. So CPS should consider information assurance. Because critical infrastructure, such as finance, aviation, medical, automotive, directly and broadly affect human life, high assurance must be considered and applied and guaranteed for the critical infrastructure. Let's see it more concretely. ISO IEC 29128, it means verification of a cryptographic protocol, and ISO IEC 15408, it means evaluation criteria for IT security. They are focusing on reliability and security. On the other hand, ISO 26262, it means road vehicle functional safety, and DO 254, design assurance guidance for airborne hardware. They are mainly focusing on safety and reliability. This table shows assurance level for each standard or regulation. I want to talk about ISO IEC 29128 and ISO IEC 15408, which have both reliability and security. At first, let's see a verification of cryptographic protocol. I mean ISO IEC 29128. There are a total of 4 assurance levels, and from up to PAL3, it requires a formal description of protocol specification in a tool-specific specification language. The language's semantics is mathematically defined, and self-assessment evidence to PAL2, PAL3, and PAL4 also require tool-aided verification. And next, let's see ISO 15408. It means Common Criteria. Common Criteria Evaluation Assurance Level, EAL, have a total of 7 levels, EAL1 to EAL7. After EAL4, that is EAL5, EAL6, EAL7, requires semi-formal or formal verification of design and test. For better understanding, I added this table. This table shows corresponding assurance level between ISO 15408 and ISO 21928. High assurance is considered at over EAL5 and PAL3. Like ISO 15408 and 29128, the higher assurance level, that is, to achieve a higher assurance, all evidence should be measurable and mathematically provable. So that's why we need formal verification, and some tools can help this process. In many countries, testing, evaluation, and certification methods to achieve higher assurance are researched. There is a control system security center in Japan. It is Technologies Research Association, and one of its major business activities is system security verification. System security verification is to establish verification method and execute evaluation of real system and components. As you can see, there is a test bed like a picture below in the CSSC. Control System Security Center. Because of many library and test tool, I think it also may help formal verification. I'm curious about what tools and what libraries are in their test server and what test they do for verification. Another project is in the United States. There is a program called High Assurance Cyber Military System hosted by DARPA. HACMS is a program for making high assurance of cyber physical system, and key HACMS technology include interactive software synthesis system, verification tools such as theorem prover and model checker and specification language. Until now, I presented background knowledge for this presentation, and next, my friend Inhyuk will present for automated tools for security testing and evaluation. Thank you.
We explained meaning of information assurance and necessary of security engineering for high assurance. Now, we will introduce the assessment features of automated tools for security evaluation and how can we apply these automated tools to security evaluation. Nowadays, the study related to automated vulnerability detection technique more active than ever in hacking community by Cyber Grand Challenge. For a long time, automated vulnerability detection technique is steadily researched for software security in academic as well as in hacking community. Then, why do we need automated tools? In fact, meaning and goal of automated tool for hackers, bug hunters, and meaning and goal of automated tools for security evaluation is clearly different. Let's talk about that in more detail. Hackers and bug hunters apply the automation technique to vulnerability detection tools for finding unknown vulnerability, like 0-day, more easily. But in security evaluation, automated tools are used to achieve the goal of evaluation. If then, what is the goal of security evaluation? In that graph, security evaluation must make the same result regardless of security evaluator's capability. And in-depth result of security evaluation is ensured when security evaluator manually perform security evaluation. But in this case, it may cause a lot of mistakes. So it is ideal that use the qualified automated tools for deriving objective evaluation result. Ultimately, the reason for applying automated tools in security evaluation is that ensure high assurance from very little effort. If then, is it suitable to use tools for hackers in security evaluation area? My answer is it's not suitable yet now. Because we consider variety things in order to use in security evaluation automated tools. When you apply these automated tools in security evaluation, we consider we consider variety things in order to achieve the goal of evaluation or ensure high assurance. Then, when we choose automated vulnerability detection tools for security evaluation, what should we consider? I will talk about assessment features for automated tools in 3 wide range. First one is user-friendly. User-friendly is easy to use in the evaluator's perspective. Next one is effectiveness. Effectiveness is important because security evaluation is conducted limited period of time. During that period, evaluator ensures the assurance for target of evaluation by using automated tools. Last one is scalability. Scalability is considered the tool's scalability because in security evaluation, variety target of evaluation are tested. Naturally, more detailed features are different by security evaluation level, detail level, or phase. However, I will explain the various automated tools based on these three features. First, we talk about tools for design assurance. These are assessment items to choose automated tools for design assurance. User-friendly is composed of usability, analysis report, requirement to evaluator. Usability is just usability. In this case, we consider UI such as graphic or command line, or accessibility or install to use, easy to install. Analysis report check whether the tool provides the test report. If tools provide the report, check that it is provided on easy to understand. And requirement to evaluator checks whether the tool demands the additional requirement to security evaluator. If tools requires additional requirement, we check tools detail requirement. Second is effectiveness. Effectiveness is composed of automation level, model description method, and licensing cost. Automation level is tools automation level. It's divided to fully automated and interactive and manual. Method, model description method is generation method of model. In other words, which language are used to generate model. Model of system or protocol software implementation. And licensing and its cost is divided to open source, free, commercial. If it is commercial tool, we check tools prices or maintenance cost. And scalability is only one element. Supported platforms is tools learning environment. For example, only Linux, only Windows, or Mac, Linux, Windows, like that. There's a typical type of design assurance, model checking method, and theorem proving based method. Simply saying, model checking is checking method for specific system states by abstraction. I means modeling or system states. Next, theorem proving based, it looks like a logic calculator. It proves user theory with logical symbols and specific language. Now, before we talk about design assurance tools, I would like to say one thing. All tools in design level, there is a common feature. There is automation level is interactive. Because these tools need a model that abstract from near software protocol system implementation. So if evaluators use these tools, then they should create a model directly using specified method, such as script or formal language. In addition, the evaluator must have ability of understanding protocol and modeling to create the model. First, NRL protocol analyzer. It's developed by University of Illinois, and it generates model by using MAUD protocol specification language. And next, FDR, failure divergence refinement. It developed by University of Oxford, and it generates model by formal language CSP. And CIDR is also developed by University of Oxford, and it generates model by standard page description language. We will show some demo for it later. And ProVerif is developed by Prosecco, and in use PV script to generate the model. ProVerif also provide web version is to access. And Isabel and higher order logic is through theorem proving based tool. Theorem proving based is calculator, logical calculator. And it is developed by Cambridge, University of Cambridge, and use functional and logic language. So evaluator use this HUOL, and they prove their theorem. And now we talk about code levels automated tools. These are assessment items to choose automated tools for code assurance. I want to skip same part before I mentioned in design level. In here, in effectiveness, analysis method is technique and tools attribute for code assurance, such as static analysis, binary analysis. And detectable vulnerability type is the type of vulnerability that tool can detect. Code coverage is a measure used to describe the degree to which the code or program is executed when a tool runs. But almost modern tools, in principle, code coverage is increasing as time goes by. And supported language is tool supporting for target of evaluation. programming language like C, C++, Java, or low binary. These are this year's finalists of CGC. I simplify the CGC CRS process. CGC wants fully automated security testing for software, no human intervention, and only machine. In this process, I think it is very appropriate for security evaluation. First three tools are source code analysis tools: Fortify, Code Sonar, and Checkmarks. Fortify is really used in evaluation agency to detect known vulnerability based on OWASP, SANS, CWE, and FISMA, and so on. So I really want to use these tools for today's demo. But I emailed and requested each vendor for trial review. No reply from each vendor. So this information are taken from vendor's datasheet or case study. All these source code tools are automation level is fully automated, so easy to use. When you use this tool, you just throw your code in the tool. Then the tools result the detailed report about vulnerability type, vulnerability root cause, etc. And CLE and Mayhem, SAGE, AFL is a binary-based automated code assurance tool. But these are automation level is interactive. For example, AFL is today's famous fudger, I think. But it is very evaluator's perspective. It is very hard to use because we learn this tool for binary or software. You need crash analysis ability. You need ability of crash analysis or root cause analysis. And this is IoT Cube. It developed by CSSA Center. Yes. This is it provides white box testing and black box testing and network testing in web browser. You access to easy. I will show demo for this IoT Cube. And I want to, as I mentioned, CGC is very appropriate for security evaluation, find vulnerability or patching or reports. But CyberGrant Challenge operating system is limited and customized OS. So not now. So we tried to install the mechanical fish of Shellfish CRS, but later I will explain about these tools. So we check important assessment features and evaluate the tool. So in security evaluation, it is important to maintain same result regardless of evaluator's capability, and result must be objective. As you may know, source code analysis tools use and reflects known vulnerability in CVE, CWE, etc. Conventional security evaluations focus on source code analysis, but it cannot detect unknown vulnerability or vulnerabilities in execution environment like memory corruption, type of memory corruption. And also, purging tools may be useful to hackers, but it's not suitable to use for security evaluation because it cannot guarantee objective result, and sometimes it needs long time and users' own capability. So it's not enough for achieving high assurance automatically with these tools. For achieving high assurance by using automated tools in whole system lifecycle, static and dynamic analysis method to binary and source code must be integrated with efficiency and measurable mathematically. Let's see some demo for our implementation. We choose same target of evaluation is OpenSSL because it is widely used security protocol and usually used to protect information transmit between browser and servers. So we apply design and code assurance to OpenSSL. First, I quote the simplified TLS key transport protocol from book, name, protocols for authentication and key establishment. Use simplified TLS key transport protocol, and we implement model and generate model using CIDR. This is protocol specification. Below, A is client, B is server. This protocol transports the pre-master secret key from client to server. So N is nonce. In standard TLS specifies use of RSA public key encryption. And digital signature algorithm is use private key. And PMK is pre-master secret. And KAB is session key from PMK and nonce A, nonce B. And in this phase, we use 3 message sequence. Message sequence is hashes of sequence of all previous exchanged message. Now, we verification by using CIDR for demo. The left, at the right, it is CIDR specification, and I generate model for simplified TLS transport protocol. In this model, we use LOL I and LOL R. I is initiator and R is responder. In this case, initiator is client A and R is server B. So as you see before I present, this phase is about TLS simplified transport protocol. So in this macro is, as you know, in C or C++ is macro defined. So we predefined about message sequence 1 and message sequence 2 and message sequence 3, and symmetric key KIL. It makes from PMK and nonce A, nonce B. And execute CIDR program and open my model. And I click verified protocol. Then automated CIDR analysis our protocol, and we use is claim keyword. Claim keyword is what you need check about security protocols for your model. So this claim is 7 is quote from Needham Schroeder protocol, a case study. So as you see result, the secret NI, secret NR is fail because we send nonce is plain text. So it is probability of attack. And PMK is people send encrypt Bob's public key. So it is secured from attackers. It's here. And you can click this pattern and you can see the diagram of these protocols and attack protocols, attack process. And we, as I mentioned, we try to install mechanical fish because mechanical fish is published open source, but in Shellfish's GitHub, they write this red box. Keep in mind that this was never designed to be turnkey, might not install without extreme effort, and might not work without a lot of tweaking. Otherwise, have at it. So I failed. So I did not prepare for this demo. And IoT Cube is, let's see the demo. IoT Cube is developed by CCSL Lab and CSSL Lab and CSL Center for and Korea University CSL Lab. And this white box, I tested white box testing. You can download in HashiMarker. Please see demo. Sorry. You can download HashiMarker, and it can detect code clone with HashiMark function. So I input the OpenSSL directory and generate hash marks. There is a two option. One is abstraction off option and abstraction on option. If you turn on abstraction off option, you can detect exact clones only. But if you check abstraction on option, you can detect near miss similar clones, not exact code. Include exact clone. So very long time. So skip and finish the hash marking, and it'll result the HIDX file. So you can get access here and drag and drop HIDX file. It supports C and C++. So in this case, this program about code clone detects. In this case, I checked abstraction on, so it can detect exact code clone. And this is a source tree for code clones detection. Sorry. And for demo, I installed AFL to OpenSSL 101 app for Heartbleed vulnerability. But for 2 weeks, but crash is not generated. So I just attached a screenshot. So conclusion. There are many kinds of vulnerability detection tools developed by hackers, researchers. In present, we use these tools for security testing and evaluation, but there are some limits. Objectivity, coverage, like efficient, and usability. Recently, many of hackers research and develop automation tools that can find unknown vulnerability easily. But we can't apply these tools to security evaluation immediately. But if fully automated security testing techniques are developed and we make an effort to apply it for evaluation continuously, achieving high assurance is not far. Thank you.